Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. Motherboard issues are among the most serious and complex problems a technician may face, often manifesting as startup failures, post errors, or complete power loss. These failures usually appear early in the boot process, before the operating system has a chance to load. A system that refuses to turn on, produces error codes, or fails to display any output often points to a motherboard-level malfunction or configuration issue. Diagnosing motherboard issues requires careful isolation, methodical testing, and a strong understanding of power delivery, signal paths, and basic diagnostic principles, all of which are critical skills for success on the A+ exam. One of the earliest checkpoints during system startup is the power-on self-test, or POST. This process runs as soon as the system receives power, and it is managed by the system's firmware. POST performs a series of low-level diagnostic checks on critical components like RAM, CPU, GPU, and storage interfaces. If any of these tests fail, the system may display an error message, emit a series of beeps, flash LED indicators, or simply fail to complete the boot process. POST occurs before the BIOS hands control over to the operating system, making it one of the most useful stages for early diagnostics. Beep codes are among the oldest but still relevant methods for conveying POST errors, especially on systems without onboard displays. Each motherboard manufacturer uses a unique series of beeps to indicate specific issues. For example, 3 short beeps may indicate a RAM issue, while continuous beeping might point to a video card failure. Since the patterns vary, it is essential to consult the motherboard's manual or the manufacturer's website to decode the exact meaning. Beep codes are particularly helpful when visual output is not available and serve as the first signal that POST has failed. Some motherboards, particularly those in business class or enthusiast systems, include LED or numeric diagnostic codes as part of their onboard display. These codes correspond to specific stages of the POST process and make pinpointing hardware problems faster and more precise. Instead of vague symptoms or long beep patterns, the technician receives a direct code that can be matched to a list in the manual. This method is efficient and ideal for detailed system diagnostics, especially when dealing with complex builds or multiple potential failure points. A complete lack of power. No lights, no fan spin, no signs of activity, requires a different approach. This scenario could be caused by a failed power supply unit, a shorted or dead motherboard, or a fundamental electrical fault. Because the motherboard is central to power distribution and coordination of components, its failure can mimic a total system shutdown. The first priority in this case is to verify whether power is being delivered to the board at all before assuming motherboard replacement is necessary. Diagnosing a no-post condition is different from diagnosing no power. When there is no post, the system powers on but does not produce a display or complete boot process. When there is no power, the system appears completely dead. Technicians use tools like multimeters or dedicated PSU testers to verify whether voltage is reaching the system. If power is present but post fails, the problem is likely with the motherboard or connected components. Differentiating these scenarios is essential to avoid replacing parts unnecessarily. One of the simplest causes of power or startup failure is an improperly connected case power button. The motherboard uses a front panel header to receive signals from the case's power switch. If this connection is loose or misaligned, the system may not respond to power button presses. A simple test involves bypassing the switch by briefly shorting the 2 power header pins with a screwdriver. If the system turns on, the problem lies with the case wiring or switch. Resetting the CMOS may also help recover the system if it fails to boot after a power event. Physical signs of a damaged or shorted motherboard may include visible burn marks, bent CPU socket pins, or no response after replacing all removable components. Swollen or leaking capacitors, clicking sounds, or sparking noises are strong indicators of internal damage. Even if the damage is not visible, A motherboard that shows no activity despite being paired with a known good PSU, CPU, and RAM is likely failed. At this point, replacement is often more practical than attempting repair. To isolate the problem, technicians should reseat or remove components one at a time. Remove and reinstall the CPU, RAM, and GPU to ensure no bent pins or poor contact is preventing post. If possible, test the system with only a single RAM stick, alternating slots to identify failed memory channels. Disconnect all non-essential devices, including hard drives, optical drives, and USB peripherals. A minimal configuration CPU, one RAM stick, and onboard video simplifies testing and helps isolate the fault to the board or one specific component. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. External devices can sometimes interfere with the motherboard's ability to post properly. Faulty USB devices, defective keyboards, or damaged external drives can draw excess power or send corrupted signals to the system during startup. To rule this out, disconnect everything that is not required for basic functionality, including all USB devices, external monitors, and network cables, and attempt to boot the system again. If the system successfully posts after removing these peripherals, reconnect each device one at a time to isolate the offending component. This method is simple, but often reveals unexpected causes of post failures. When troubleshooting persistent post failures, motherboard reset options become particularly useful. Most boards offer a CMOS reset jumper or allow the removal of the CMOS battery to clear the BIOS settings. Resetting the BIOS can restore default values, which may resolve issues caused by corrupted firmware settings, failed overclocking attempts, or misconfigured hardware profiles. When using the battery removal method, it is important to leave the battery out for several minutes before reinstalling it to ensure that all residual charge is cleared and the reset takes effect. BIOS corruption is a less common but serious cause of boot failure. If the BIOS update process is interrupted or a flash chip becomes unreadable, the system may fail to display anything and remain unresponsive at power on. Some modern motherboards feature dual BIOS systems that allow automatic recovery from a corrupted primary BIOS. Others may support USB BIOS flashback, which lets technicians reflash the BIOS even without a working CPU or RAM. If BIOS recovery options exist, they are usually documented by the manufacturer and require careful following of step-by-step procedures. Thermal shutdown symptoms can also mimic motherboard failure. A system that powers on briefly and then shuts off, or one that refuses to stay powered, may be reacting to an overheating condition. If the CPU fan is disconnected, if thermal paste is missing or improperly applied, or if BIOS settings include aggressive thermal protection thresholds, the motherboard will trigger a shutdown to prevent damage. Verifying fan connections and inspecting heatsink installation is critical when diagnosing systems that power off shortly after boot. Power delivery issues can cause permanent or invisible damage to the motherboard. Electrical surges, brownouts, or miswired power supply units can destroy onboard circuits even without leaving visible signs. A board exposed to such conditions may appear intact but remain completely unresponsive. Using surge protection and high-quality power supplies can help prevent such failures. If a system fails following a power event, testing the PSU separately and visually inspecting the board for signs of damage are important first steps before assuming failure. Deciding when to replace a motherboard rather than attempting repair depends on cost, complexity, and component compatibility. Most modern motherboards are not economically repairable due to the complexity of integrated circuits and surface-mounted components. If the board is under warranty, replacement is usually the best option. When replacing, technicians must ensure compatibility with the existing CPU socket type, RAM generation, and case form factor. Documenting model numbers and chipset types helps streamline the replacement process and avoid incompatibilities. Manufacturer support resources can assist in diagnosing and resolving motherboard-related problems. Some brands offer online diagnostic flowcharts, BIOS downloads, or support chat tools. For boards under warranty, the Return Merchandise Authorization, or RMA, process typically requires proof of purchase and a description of the issue, including steps already taken. Providing detailed documentation of the problem, such as beep codes, voltages, and diagnostic results, helps validate the claim and may expedite replacement. When replacing a motherboard, technicians must take precautions to avoid damaging the new board during installation. Electrostatic discharge protection is essential. Use wrist straps and work on anti-static surfaces. Avoid over-tightening screws that could crack the board or dislodge embedded traces. Verify that case standoffs are properly aligned and that no metal points are making contact with the board's underside. Double-check that all power, data, and front panel connectors are securely and correctly attached before powering on the system for the first time. A typical motherboard failure scenario might go like this. A user reports that their desktop has stopped powering on entirely. The technician confirms that the power supply passes testing with a PSU tester. No fans spin and no lights appear on the motherboard. After checking front panel connections, the technician tests with a new RAM stick and a known good PSU, still with no result. Closer inspection reveals a discolored capacitor near the CPU socket. The motherboard is replaced, the system posts successfully, and the technician documents all steps, test results, and the final resolution in the ticket. In summary, effective motherboard troubleshooting relies on isolating symptoms, interpreting post-feedback accurately, and verifying power delivery before assuming component failure. Technicians must test with known good parts, utilize reset tools, and rule out external device interference. Motherboard replacement should be the final step, taken only after all other possibilities have been exhausted. This methodical approach minimizes downtime, avoids unnecessary replacements, and ensures a clear resolution backed by evidence. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.